This is the vlog for Unit 6, which is the unit on three-variable equations and logarithmic properties. The sample question I am using to demonstrate this unit was solving for x in the equations 9 equals 5 to the power of x, 5 equals x to the power of 9, and 5 equals 9 to the power of x minus 1. These are all exponential functions, which are the relationship between an input and an output in which the output increases exponentially. This means that the y value can double or triple or quadruple depending on the exponent, making the graphs look like this. You may not see the application and importance of exponential equations by just looking at this graph, but exponential functions are everywhere. Some examples include population growth, the increase of the number of extinct species, bacteria growth, and the increase of use of cell phones. This may sound confusing before you understand the different parts of an exponential function. The equation of a basic exponential function is y equals b to the power of x. Y is the answer or output of the equation, b is the base, and x is the exponent or the input. For example, 3 to the power of 4, 3 is the base or b, 4 is the exponent or x, and the answer or y is 108 because 3 times 3 times 3 times 3 is 108. These problems are not quite as simple. They include more steps, you will need a calculator, and the answers will not be as clean. Let's start with the problem number 1. 9 equals 5 to the power of x. You can clearly see that x cannot be multiplied by itself to go into 9, so it would not be as simple as 5 to the power of x equals 25 or 125. You will have to come at it from a different approach. Luckily, there is a way to rewrite exponential equations where you input the base and the answer and get the power instead of inputting the base and the power to get the answer. This is natural log. Unfortunately, you can only use natural log on a calculator. The format for natural log equation is natural log of the answer divided by natural log of the base equals the exponent. So 9 equals 5 to the power of x would be replaced with natural log of 9 divided by natural log of 5 equals x. If you plug that into a calculator, you will get approximately 1.365. So 5 to the power of 1.365 is approximately 9. Question number 2 is found differently. The equation is 5 equals x to the power of 9. For this equation, you can just try and get x alone. To do this, you will want to cancel out the power of 9 over x by 9th rooting it. But if you do this to one side, you have to do it to the other as well, so instead of 5 equals 9 to the power of x, it will be 9th root of 5 equals x. Next, you will plug in 9th root of 5 into a calculator, and the answer should be approximately 1.196. So 1.196 to the 9th power is approximately 5. Now for question 3. 5 equals 9 to the power of x minus 1. This is very similar to how we did the first question. You are going to use natural log. So as I said for the first problem, the format when you are changing an exponential equation to a natural log equation is the natural log of the answer of your exponential equation divided by the natural log of the base of your exponential equation equals the exponent of your exponential equation. In this case, the answer is 5, the base is 9, and the power is x minus 1. So the equation would look like natural log of 5 divided by natural log of 9 equals x minus 1. You have to solve just for x, so you have to get x alone like you did in question 2. You can cancel out subtracting 1 from x by adding 1 on both sides of the equal sign. So you will plug the equation natural log of 5 divided by natural log of 9 plus 1 into a calculator. The answer should be approximately 1.732. This means 9 to the power of 1.732 minus 1 is approximately 5. This concludes the Unit 6 video. Thank you for watching.